Today we are going to talk about the different models of atom that are used to study the atom. Actually, there are three models, but finally we will see that only one is used for studying because it is the easiest. This is the one, the Bohr's model. Now let's start from the first one. They are three: the electron cloud model, and Bohr model, and finally the space filling model. First, the electron cloud model that shows this model that was found finally by the most current theory of atom, the most current atomic theory, which says that the electrons are moving in a cloud over around the nucleus. The nucleus includes protons and neutrons, while the electrons are moving in a cloud very quickly, that they can't be identified where they are located, or what is the speed of the electron, what is the location of the electron, can't be identified. So they decided that they are moving in an electron cloud. This is the first. First, this is correct. This is the most true one. But about if we can use it for studying, it can't. It can't be used for studying. Why? Because it doesn't show the number of electrons and the energy levels of the electrons can't be shown. Okay? So this is the first one. The second one, and this is the best for studying, the Bohr's model of the atom that shows the number of electrons clearly. It shows the energy levels. The electrons are shown as dots placed in rings around the nucleus, with each ring representing an energy level. Showing the electrons and energy level helps predict how and why atoms form chemical bonds. This is the Bohr's model. It shows how are the electrons distributed. Here we have, this is the first energy level, which is the nearest to the nucleus. It has only two. Then the rest, as you see here, 2, 3, 4, 5, 6, 7, 8. So which atom is this? This is the oxygen atom. This is the oxygen atom that has 8 electrons. We could see the number of electrons. We could see the distribution. In the first energy level there are 2. In the second energy level there are 6, and so on. So it is very helpful for us for studying. The last one, the space filling model, that shows the atoms as balls, as the balls that are used to make molecules with. It looks that it can show how the atoms are connected with each other. This is the closest to the reality. Okay, it can show how they are connected. It's the nearest to the reality. Okay, the spheres don't show the parts that make up the atoms. We can't see here where are the electrons, where are protons, neutrons, can't be seen. But they can show the solid spheres, how they are connected only. However, this model clearly shows how the atoms are connected to each other in the reality. That's it. This is for the three models. Very important. Please study them. If I asked you what are the three models, this will be the answer. You will say the cloud model, the electron cloud model, Bohr model, and the space filling model. You have to be able to recognize everyone also from the pictures, to describe everyone, to say the advantages and disadvantages. For everyone there is one advantage, one disadvantage, like this. Okay, what are the valence electrons? Actually, we started talking about valence electrons from the last period, right? From the last lesson, when we take the periodic table, when we talk about the groups, or the families, we said all the elements in the one group, they have the same number of valence electrons. They can have the same number of valence electrons. So remember with me, what are valence electrons? Actually, valence electrons are the electrons that exist in the outermost energy level. So if you have to differentiate here between the atomic number that gives the total number of electrons and the valence electrons. يعني here, let's go to the periodic table. Here is the periodic table. Here are silicon and germanium. Aren't they which I want? Wait. As you see, here are silicon and germanium in the period number 16. In the group number, what is this? It's number, this is the group number 14. So we can take, as I told you that's the last time, from the ones of this group number. What is the ones of this group number? We can say this is a group 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10, up to 13, 14, 15, 16, 17, 18. Okay, now in number 1 and 2 there is no problem. The number of the valence electrons is 1. Here the number of valence electrons is 2. Here the number of valence electrons is 3. Number of valence electrons 4. Number of valence electrons 5. Number of valence electrons 6. Number of valence electrons 7. Number of valence electrons 8. That's it. Okay, let's go back to silicon and germanium. Silicon's atomic number is 14. Germanium atomic number is 32. The atomic numbers are different. Okay, here we can know in the silicon that the silicon has 14 electrons. Germanium has 32 electrons. Okay, now what about the valence electrons? Let's see. Now, using the Bohr's model, we can move from an energy level to the second, like this. The first energy level can hold up to 2, only 2. Okay, 1, 2. The second energy level, hold 1, 2, 3, 4, 5, 6, 7, 8. Up to 8, no more than 8. So 2 and 8, 10. What are the rest? The atomic number is 14. The rest are 4. So 1, 2, 3, 4. The outermost energy level has only 4. So the valence electrons equal 4. Okay, now here in the germanium, we start from the first energy level, which can hold up to 2. The second energy level can hold up to 8. They become 10. The third energy level can hold up to 18. In some elements, we will see in some elements it can hold up to 8. These rules you will take them later after grade 9. So we can't talk about them now. But in simple elements, the first one 2, the second one 8, the third one 18, and so on. Okay? Now the fourth one, now they become, we said 10 plus, let's say 2, 8, 2 and 8, 10, huh? And 18, they become 28. طب 28 to be 32, what are the rest? 4. So plus 4, it will be 32. This is the total number. So here I have only 4, 1, 2, 3, 4 in the outermost energy level. So the atomic number is 32, while the valence electrons equal 4 only. You can see that silicon and germanium both have the same valence electrons. Now, why this number is very important for elements? Because it gives us the number of electrons that can only participate in chemical reactions. Only these electrons. Why they are important? Only these electrons can be used in the chemical reactions, not any of these. These are very connected. They are very attracted inside the atom, very attracted to the nucleus. They can't leave the atom. Only the outermost energy levels electrons can move out of the atom, or this energy level can receive some electrons. So the atom can receive or give or share, whatever. All of these you will learn them in the next lesson. Not this is the problem. Here we are talking about that only the electrons in the outermost energy level can be used in chemical reactions. This is the very important fact that I have to put in my mind. So that is the very important thing about valence electrons. Electrons found in the outermost energy level of an atom are called valence electrons. So here also they told us how we can use the periodic table to show the number of valence electrons. This I told you about it. Elements in the same group or vertical column have the same number of valence electrons. You can use the group number to find the number of valence electrons in group 1, 2, then from 13 to 18. You can use the ones only. The number of the valence electrons is equal to the ones. There is no simple rule to find the number of valence electrons in groups from 3 to 12. So we can't depend on the number of the group. Also, you will learn later how to distribute the electrons to can find what are the valence electrons. This will have another way, another method. You will learn it later. But please try now to understand these basics, because this will make the coming information later, what you will learn later, this will make this information easy for you. But if you don't understand now, you will find them later very difficult. Okay, so here they ask us determine the number of valence electrons in the atom of carbon, nitrogen, and fluorine. I want you to find them, and at the beginning of the next video, inshallah, I will tell what are them. But please try to find them by yourself, and inshallah it will be easy. What did we take today? We took from the book, the page that has the 3 models. For sure, this is right in the question 10. The first one, what is it? It is the electron cloud model. The second one is the Bohr model. The third one is the space filling model. Which atom is this? Right. Okay, for sure, because here I have only 1 electron, I can say that it is what? It is hydrogen, right? Okay, the second, yes, here they show the Bohr model of the oxygen atom. We had it in our PowerPoint also. Then here they talk about the valence electrons. Let's see what is the example that they give us. They gave us the example of the fluorine. The fluorine atom has 9 electrons. Draw a model to determine how many valence electrons the atom has. I want you to do it by yourself. Okay, if we said it has 9, and as you see here in step 2, it has 2 energy level. Distribute the rest of the electrons to finish the fluorine. Then inshallah the next time I will do it with you to find how many valence electrons does the fluorine have. That's it. This is everything for today. Inshallah tomorrow we will continue.